So I had a couple of things uh, I want to talk about today. One is the HDF5-json package, and the other is setting up HSDS on the Mac. So let's do the latter first. Last time I talked about setting up HSDS on a Windows laptop, and today I thought I would do the opposite. So if whatever camp you're in, you should be happy. Um, so when I was using Windows, I recall we set up Docker running in this Whizzle 2 environment. The Whizzle 2 is the Linux subsystem that gives you a pure Linux environment running on Windows. On Mac, there's no equivalent of Whizzle 2. And personally, I found running Docker somewhat problematic. So in Mac, you can run Docker, but you have to run it in the virtual machine. So rather than deal with that, I've kind of evolved to running HSDS just as a set of processes on the Mac. So I thought I would just walk through the whole process from git clone onward, and then you can see basically what is in. Bear in mind, this is just my personal setup I use for development. You may want something different. That's totally fine. And this is not what you do for a production environment in any case. So let me share my desktop. So let me go to the terminal. Uh, is this font size big enough
For me.
for anyone? Wherever has the worst eyesight. Um, let me know if it's I need want me to enlarge it. So let me start with getting the HSDS repo. Okay, so now I'll CD into that. There's one thing you need to do before running HSDS, and that is to set up your password. So if you go to admin config in HSDS, you see there's this password.default. That's like a template password. So in real life, you would create something maybe more secure than test for a password. But basically, it's just the username colon password, username colon password. So we're good with this for this demonstration. So I'm going to copy password.default to password.text. Okay, so now we'll go back up. And there's a script, build.sh. First of all, I should say I'm running Anaconda Python. So I have the Python 312, I believe. Uh, right. And if I run this build.sh, by default, that will build the HSDS package and also create a Docker image. But since we're not going to be using Docker, we can dispense with that by using the no Docker option. So if you say -H, it'll tell you these different options you have. So there's no lint, no Docker. So no Docker. So that'll go through the source code and build this Python package for us. Okay, so now we have a package HSDS 0.9.2. Now to run HSDS as a set of processes, there is this HSDS executable that will start up. But I typically run this run all.sh. And before I do that, there's a few environment variables I would set up. So in this file, I have saying the root dir. If you set root dir, that's telling HSDS to use a POSIX store rather than say an S3 bucket. Log level debug is good for developing. Otherwise, you should have info or warn. Uh, Sample bucket is used for some tests, HDF5 files. HSDS endpoint tells the test script which endpoint to use. And bucket name is this default bucket. And admin username is admin, admin password is admin, and user team. So all these are used by the test programs to validate when they're running HSDS requests. So I will do a source POSIX bash and then go back. And now we have another script, run all.sh. And this has arguments for no Docker or no Docker TCP. If you say run all.sh without arguments, you'll run in Docker, which we don't have. If you say no doc dash dash no dash Docker, you'll run as a set of processes, but using Unix sockets. And if you run no Docker TCP, then it'll run using TCP connections. I found that the TCP works better with Unix sockets. I have some issues with like multiple clients getting their messages mixed up. So let's run all.sh, no Docker TCP. So this starts 5 different processes. And once they're ready, it says ready and use endpoint blah. So let's switch to a different terminal. And if I do this, if I do, oops, if I say curl HTTP localhost 5101, that's the port number, about, I'll get an actual response from the server. So it's kind of like a status JSON. It's telling the state's ready, its version number, the name, the greeting, all these things you configure, but for now it's just the defaults. Okay, so next I'm going to get the h5-pyd package. So I can just do like a pip install h5-pyd. And if I say, actually, let me do this. If I say hsinfo, which is one of the h5-pyd command line utilities, it doesn't know where the server is. So you can do hs configure, and it'll just walk you through these different settings. So server endpoint, we saw that back here, the localhost 5101. And username, we'll use our favorite test user 1, and user password is test. API key we can ignore. And so it says, you'll see it says testing connection. So it pinged the server using those configurations and it says, okay, do you want to save changes? When you save these changes, it goes to this file.hsconfig that just has the endpoint, username, the password. All right. So now if I do hsinfo, it'll say basically the same information we saw in the curl request before. Server name, server state, endpoint, username. Home, it says no access. So, okay, what's that about? If I do hsls, so they list the folders for slash, we have no folders because we've just created a new bucket. It has no content inside. There's another command, hstouch, that you can create a folder. So if I say hstouch/home, that'll create a folder in the default HSDS bucket. Except as test user 1, I don't have permissions to create folders outside of a folder for which I have permissions for. So to get around this, you have to use your admin privileges. So if I can impersonate admin by saying -u for username, admin, -p for password, admin, and now the same folder. Okay, so now I've actually created a home folder in the default HSDS bucket. And if we do hss/, we see, aha, there's a home. But there's still not a folder that test user one can access. If I do hsACL, I can see the ACLs for this, which I can't because I'm not admin. So admin has privileges, but no one else has any privilege other than reading. So let's create a test user one folder under home. So I'll do hstouch -u admin -p admin, and now another command -o for owner. So this is saying create the folder, but make the owner not admin, but the username that I'm giving now, which is test user one. And the folder name will be /home/test user one, and very important to have a trailing slash. So all the HS commands, you'll note, you need a absolute path, right? There's no concept of a current directory or anything like that. So we'll do that, except I have a like that. So now if I do hsls/home, I see there's home test user one. And if I say hsls/home test user one, I have a pristine folder. So I happen to have a HFI file here called tall.h5. So there it is. I can upload that to HSDS using the hsload command. So hsload tall.h5, and now I need to give it a location to upload to on the server, and it'll be home/test user one/. Okay, so that ran. And now if I do hsls as opposed to h5ls /home/test user one tall.h5, and let's do the recursive option, we'll see all my content. Okay, there's another command, hstat. We'll give you some more details. So this is saying the GUID for the root group is this, last modified date, the last scan date, the undefined checksum, the total size, the allocated bytes, the metadata bytes, a number of objects, number of chunks. So this maps to our POSIX storage folder as follows. So we have one of the arguments was router, which is which I had as my buckets. And then HSDS test was a bucket name. And here we see there's home and DB. So under home, we have our test user one. And under test user one, there's a tall.h5. And under tall.h5, which actually is the directory, there's this thing called .domain.json. And if we look at that, now I'm doing this, I think this is a good segue for my second topic, but let's continue. Sorry. So this .domain.json is a bit of JSON that gives you this top level information for this HSDS domain. And we have things like the root UID, the owner, the ACLs, who can access and do what, the created timestamp, the last modified timestamp. Okay, now you might ask, where is all the other content? Where are the data sets and values and attributes and all that? Those are actually stored under DB in this key. So if we go back to the bucket and look at DB, And this. So there's you'll see this mysterious F581C. That actually matches to the top part of the root GUID. And if we look at that, we'll see there is a .group.json, .info.json, which I'll explain some other time, D and G. So the .group.json is the JSON description of the root group of this domain. So let's just cat that. Okay, so here we have things like the created timestamp, the links of this group, attributes of the group, the created timestamp, and so on. And then the subgroups of this domain are all under this G folder, under the root group GUID folder. Oops, I keep on mucking up my command. So here we'll see there are 4 GUIDs. These correspond to the 4 subgroups that happen to be in this tall.h5 domain. And correspondingly, if we look at the D folder, there are 4 GUIDs correspond to the 4 data sets. And if we look at one of those data sets, you'll see that there is a dataset.json and 0_0. The dataset JSON, now I'm going to switch this, has information about the metadata for this data set. Okay, the type, it's a float, 32 big Indian. The shape, it's 3x5. Max stems, also 3x5. No attributes, and some creation properties. So layout is chunked, and dimensions are 3x5, which makes sense because it's only 3x5, and so on. So this tells HSDS all the metadata information it needs to know about that data set. The actual data for the data set is stored in one of these chunk files. And since in this case, there's only one chunk, there's only one file, and that is the 0_0. So if we look at that, so you'll see it's 60 bytes, which corresponds to 3 times 5 times 4, the number of bytes in each element. So it's a binary image of that chunk, basically. So I guess I can do, what's the command od.x? So you can see the contents are like that. So normally you don't need to worry about these weird files in the bucket. You interact with HSDS just using REST API or using the h5py API commands that are part of h5pyd. But I thought it might just be interesting to see under the covers how that works. There's one other thing that might be useful for if you have encounter an issue or something with HSDS, go back to the HSDS repo. There is a log file that we set up whenever we had the log levels debug. So it's a little chatty. But it's called hs.log. And then you can see the information, right? So even though we're not doing anything, there's some housekeeping stuff that does periodically. And if you have an error, you can say grep for error. Hopefully we don't have any. And if you look for warnings, you'll see that we have some warnings like these are things like, hey, you asked for this domain and there wasn't a domain there. Just letting you know about that. Try to read a chunk, but there wasn't a chunk, so it said not found, that sort of thing. But sometimes you can see warnings that might be helpful to diagnose an issue. Um, okay, so that was a bit. Any questions about this HSDS setup? Of course, there's detailed install documents in the HS repo, but this is kind of like a casual dev to dev kind of discussion of how I set it up myself. All right, very good. Um, the other thing I want to mention this briefly. I've been working with this you saw some examples of describing HDF5 metadata as JSON. And this actually goes back to a project that we did some time ago called HDF5-json. So if you go to the HDF Group documentation website, you'll see there's a repo for this HDF5-json. And basically, it describes how to describe HDF5 as JSON in some detail, right? So uh, let's just take a look at this. And you'll see there are similarities to what we saw in the HSDS schema, but some differences as well. So in this example, you have this ID and the root group UID, and there's a groups and a data sets, and there's the data types. So just like in the HSDS schema, there was a folder for under D and G for data sets and groups. We didn't have any data types. The example, some data types. But just like HSDS, each object is stored by a GUID under either groups or data sets or data types. Now, you may think it's a bit unnatural. Why not, if your data set is like /G1/G1.1/dataset 1.1.1, why not have a hierarchy that reflects that? And the reason we don't, beyond being perverse, is that since in HDF5, you can have multiple links that point to the same object. You can't straightforwardly encode that in a directed graph like JSON. So instead, what we do is that we have each object, each group, each data set has a GUID. And under that GUID, we have the metadata, the attributes, the links, or the shape, so on. And then, so like if you look at a link value, so here in this group, we have a bunch of links. There's hard links, there's soft links. These links don't have a path. They have another GUID. So this is not very convenient for human readers, but computers don't have an issue with it. So if you want to find what the link dataset 1 points to, you get the ID and then go to datasets, since you know it's a datasets collection. You go to the datasets and find this ID and then retrieve its metadata. So there's another convenience too, is that if you say you want to modify a link, let's say I want to delete this link dataset 1 and change it to dataset 1_mod. If we were storing this information hierarchically, it'd be problematic, right? We have to move all those sub-objects around. But this way, we just need to change that one metadata object, the link itself, not move any of the data it may be pointing to. Some differences between this and HSDS. For one, everything is in one cohesive file, whereas in the HSDS schema, we have separate files for each object's metadata, separate files for each chunk, and so on. that works better for things like with S3, where you can't incrementally modify files. You have to rewrite the whole file. Um, and also in HDF5-json, you'll notice that the dataset values are in JSON, which is readable, but it's not very practical for really large data sets. So instead, as you saw in HSDS, we store these as binary blobs. So I think, even though we haven't had a lot of people asking about HDF5-json, it's a very comprehensive take on the somewhat complex ins and outs of all different varieties of HDF5 data. And so if you're curious, take a look at it. I can see ways this could be used in many different circumstances beyond just HSDS. All right. Okay. There's more to it, but I think we're running short on time, so I'll leave it at that. Any questions about the HDF5-json package?
Yeah, John, do you know anybody right now who makes use of the JSON package in any way?
Uh, there was a product we had a while ago called the Product Designer that used it. So initially, we had kind of seen this HI-JSON as a kind of common substrate that different packages could use. Over time, the only one I'm aware of is the HSDS. That doesn't mean that someone out there isn't using it. All the time I find out that someone who I was very surprised will be using something that I wouldn't have thought they were using. So I don't know. If you hear of anyone, let me know, and I'd be delighted to see how they're using it.
Okay, all right, thanks, John.
Okay, awesome. So if no more questions, I'll see you guys next time. Thank you very much for attending.
Thanks, John. Bye, everyone.